Solve problem F. So in this problem, we need to have a lot of observations again. So first observation, consider the corner be some x, and the cell to the right is x plus 1. The thing is, when we have x and then x plus 1, the next in the next row we will have also this and also like this and so on, and we can't change it. The same goes if we have -1, the same goes if we have x. So it seems that the first row is determining the others uniquely. So after that, you can also have something like, let's say x plus 2, and if you have this, then again x plus 2, and so on. So, and if this is x, and you can have the next row different. Let's say you have x minus 1 here. If you have x minus 1, this will be x minus 1 too. And then it will result in x minus 1, x minus 1, and so on. So either all of the rows are, so every row has single number, or every column, or both. So this is the first fact. So this is the first fact, that either we can find all of the whole matrix, the whole, what is this called, grid, by having the first row, or we can find the grid by just the first column. So let's focus on that. So now we want to find an array of size n that satisfies our conditions. And if it satisfies our conditions, then we can make some grids using that by copying into other rows, or by putting it as column and then copying to other columns. And there is a case that all of the elements of the array are 0 or 1, 2, 3 to 9, that we need to make sure we are not counting the duplicates. So now we want to build some array. So let's see what are these bad rectangles. So first, bad rectangle is an array actually. So bad rectangles can happen when the rectangle has more than one rows and more than one columns, like this. This is here, but actually this is not valid because it's not following this. Okay, so it's not valid. Let it go. So it's just one-dimensional, and let me tell you when a rectangle is bad. A rectangle is bad if it's strictly increasing or strictly decreasing. So the problem is asking us actually to find number of arrays of size n that they don't have any subarray of size k plus 1 is strictly increasing or decreasing. That's it. Okay, that is very easy. So it's just it's just dp. That's it. We'll do dp. That's it. So let's do the dp, and we'll implement some function solve and so on. You'll see. First of all, let's get n and k as input. We don't have test cases. What is it? In n and k. And k. Then let's define function solve or dp that has n and also a streak and also last and we'll answer that. And finally, what we do is making a for loop on last, like have here D, then with the sort by 0 and go to D and plus I, and then let's iterate over a streak, which can be maximum of minus D and minus K, because we don't want to have a streak more than K, so this streak can be negative. So here, I mean, by negative, it means that it's strictly decreasing, and here we have minimum of D, because we can't have more than D, it's obvious. And then K and plus streak, and then as we have here, let's copy paste my mode int here. And we don't need all this, and then mode int ans, and ans plus equal dp. So let's change it to mode int 2. This would be much easier. And I and the streak and print the answer. That's it. But just wait here. We need to multiply all these by 2 because we can put them in columns or rows. And finally, we need to decrease it by D. Why? Because we are counting the number of tables twice. Very good. Let's start from here. If streak so a streak if a streak is okay, here I have summed up that what does a streak 0 means, because it can't be 0 ever. The streak is always at least 1 or minus 1 and 1 and minus 1. They don't differ. So let's define it somehow different. That a streak means how many adjacent pairs we have actually, that they are going up or down. So like if a streak is 1, it means that we had 2 integers, so 1 jump, 1 plus 1 jump. So when a streak is like 9, it means that we had 9 jumps, something like that. And we need to change some things here in because this is not acceptable. This is not acceptable. Let's modify them, because this is not gonna be possible. If that's not gonna be possible, then I have to do this and plus 1 here. Okay. So when if a streak is more than 0 and it's positive, we can just return dp of n minus 1 and less minus 1 and the streak minus 1. And if the streak is less than 0, actually when it's 1, the result will be different. So length plus 1, the streak plus 1. Okay, give me some moment, I need to think a bit, we'll be back. Okay, so we have some cases here, and finally we need to put some base cases too. So if a streak is 1, what we understand is Um, Last element is actually this element -1, but the streak that was leading to that was something positive. So it's like arms, then for this can be any positive. So, or no, sorry, any negative. It must be more than maximum of, like this, exactly like this. It must be more than this, minus minus s, and s plus equal dp minus 1, less minus 1, and s, and finally return s. Okay. So this is this. Same goes when another case if the streak is 0. The streak is 0. Either n is 1, which we will just return 1, or we'll return n minus 1, just this number, and any streak. So again, we have to have this thing here. So let me solve that case somewhere else. This is this, while it's less than this plus s, and you return s, and if it's 1, this goes, and if the streak is -1, then 0 is okay, and we copy paste from here. Then it needs to be less plus 1, and streak, any streak that is positive, yeah, positive streak, and positive or at least non-negative. So this seems good to me, and now we need to put base cases. If n is 1, just return if the streak is 0. What are other invalid? If less is less than 0 or less is more than d, return 0. Then what else? What is bad? N can't be less than 0. It's bounded. Less is bounded. This streak is bounded. Seems that it's okay. So finally, we need to cache answers to make sure that we are not solving a DPA state twice. And actually, it's not that easy because we have a lot of returns here. But we'll figure it out, don't worry. But for a start, doesn't matter, we can give an example to see what happens. Okay, it's working. What about this one? Perfect. Okay. Boom. Then max n. What is max n? 2e2. Then last is d. Then 2 times d. After these things, if solve, and then we need to add this because this can be negative. Put in cache the same array. Here I can use a trick. Optional. If hash the has value, return what? Return this. That's it. Otherwise, what I will do here is defining this and bind it to its value. And here I will set answers. Again, unzip. Again, unzip. And finally return ans. Okay. Let's see if it's working. Oops. First, we need to set it to 0. Then bind value. Okay, let's submit. I think that here we could use a better, maybe efficient idea, but we will see. Maybe I will clean this code more and put it for you. Okay, submitted. Let's see. Why we didn't use a very large test case to see what happens. Always easy to test codes of this type. I'm not sure, but at least it's not printing gibberish. So this mode int class is very good. I suggest everyone to use it because it makes it easy to work with such kind of problems, and we got the right answer. Let me debug and I will be back. Okay, I understood what is the issue. So the issue is actually not that hard. So look, this table, I'm not counting it. So the fact that I told you that all of the rows are equal, I mean, for each row, every element is the same, or for each column, this was not true. So like this, so this table is valid, right? But it doesn't follow what I said. Let's fix our solution. So this correct solution is you need to determine the first row and first column, and other elements will be uniquely determined. That's obvious, right? Because when we have the first column and first row, the first element, I mean, in the second row, second column, it will be determined, and then all the second row and the third row and so on. So all the elements will be determined uniquely. So I have something here for you. So consider that here we have X, Y, T, U, and Z, and Q. So this is uniquely determined, this is 2, and this is 2, and also this will be T plus Q minus X. So if you want to find a specific cell, you just need to add the number above it, so the first cell in this column, and also first cell in its row, and deduct the X here. So it's T plus Q minus X. So consider we have a lot of such things, and here we have something like, let's say A, and consider here we have B, so this cell will be A plus B minus X. This was the first observation is this. So this was what I understand that I made mistake. The next one. The next one is I told you that bad rectangle has always one row or one column and it can't be two-dimensional, but it's wrong too because the first observation that it was built on it, it was wrong, so it's wrong again. So we need to fix that. So a bad rectangle is a rectangle like let's say 1, 2, 2, 3. This is a bad rectangle. This is also a bad rectangle, and also this. Same goes for this. These are all examples of bad rectangle. So bad rectangle is a rectangle that it has a corner. It has two opposite corners. The distance between them is exactly number of columns plus number of rows minus 2, like here. 4 plus 3, like 4 plus 3 is 7, minus 2 is 5, and 1 and 6, their difference is 5, which is true. So this is a bad rectangle. Given that, our solution will not change a lot. The thing is, based on what we discovered, that we can find any cell like this, we can say that if we want to avoid a rectangle, let's say it has R rows and C columns, that its area is more than K, we shouldn't have any subarray in the first row that is strictly increasing or decreasing, and its length is C, and for columns we can say R. So if we have consecutive or strictly increasing or decreasing elements in columns and also C in rows, we will have a bad rectangle of size R times C, which can be bad. So we need to make sure that this doesn't appear anywhere. Let's add a parameter here, max 3, that we will never exceed this. And then we need to add another dimension here. Then max 3 here, and so for this, and so for this, and also here we need to put, then here we need to modify, then here, then here we use minus max 3. I will fix this, I will tell you how. But here we put, here we put, here we put. Let me define another function like this. I will tell you what it will calculate, and I will implement it here, and it will do a for loop on streak L to streak R, and it will returns the answer. Yeah. Like this. And here I will have this, and finally I return the answer. In last max streak and is true. So here ans is calculating DP and setting this to be minus max streak to max streak. We can remove this. Here, last minus 1, then minimum is minus max streak, and this goes like this. And here, last plus 1, max streak from 0 to max streak. And now my code is shorter and cleaner, and we are ready to do something here. So we look over the corner, the top left corner, and we'll set it as last. And then we will look over let's say round streak, which is like this, and then we will look over color streak, which is like this, and then if round streak plus 1, because our streak is the actual streak minus 1, so I need to add 1 here, color streak plus n. If it's less than or equal to k, I'm gonna add the answer. And what is the answer? It's dp and then I, and then max streak is round streak, and then L and R are basically everything. So round streak minus round streak and round streak times wait, here if I do like this, I'm gonna count some options twice. So I will define another dp here, mod int dp is just 3 parameters. This that will handle this efficiently for me, and it returns dp in last max streak minus max streak to max streak minus if max streak is not 0, I will do the same, but for okay, I will do the same. Oops, why it's okay, no problem. Max streak minus 1 plus 1 minus 1. The thing is, when we set max streak, we are also counting options is max streak minus 1. So for calculating the options that are exactly equal to max streak, I need to deduct the number of salaries with the constraints that are minus 1, 2. So this will work, and this is gonna call this okay, and then an I and call it streak. Okay, and let's print it. I'm not sure No problem. I'm not sure it's gonna give us correct answer, but let's try. 10, correct. And let's convert it to this. I think it's wrong because I think answer should be 78. But let's submit and then we'll make sure this is correct or not. Okay, submit. Why it should be incorrect? Okay, we have again wrong answer on test 3 and for test 8. Okay, let's see what happens and we'll be back. Okay, this is gonna be a long story. So, there was a mistake in my code that led to wrong answer, and the case that we are counting and we shouldn't count is this. So, look at this. This is valid, and this 8 and 9 is valid too, but it makes a 10 here, which is not valid. So what we want to do is to modify our DP. So our current DP is n last max streak and the streak, and we need to add to the other parameters last and let's say L and R. So what does it mean? L and R means the range that you can pick numbers in the array. So actually all the array elements are going to be in L and R except the last one, because the last one would be the corner and limitation for that is different. So what I'm gonna do is consider we have x here, y here, and z here. We need to make sure y plus z minus x lies between 0 and 10. To make sure this happens, we can use this L and R. So let's see. If I want to keep all these things together in my memory, I will get memory limit exceeded, so we can't do that. So we will use two layers, and DP here, D here, so it's okay. Then let's do this. Then let's return this one. Don't worry, you'll see what I'm gonna do very soon. Here we have L and then we have R. I'll remove the rest very soon. So here L R, and then finally LR we have to add here too. LR, okay. So let me make a border here. So we start from 1, we go to n, and we proceed like, let's start from 2. So dp in, oh sorry, 1, no problem. Let me change this to this one, and then okay, let's make a for loop on L, which is 0. L should be less than this. L plus plus, same goes for R. Then let's for on last, but here important note is if I is n, I will start from 0, otherwise I will start from n, and last is always less than or equal to if I is n, d minus 1, otherwise r, then plus plus last. Then let's go for max streak. Max streak is 0, max streak is less than or equal to d, less than d, and finally the current streak. So 1, 2, 3, 4, 5, 10 to the power of 5 times n. Current streak starts from minus max streak. What? And goes to max streak, and now. So there is, yeah, let's solve it like this. We will copy paste from here. If a streak is more than 1 dp up, let's find answer to this. Not int and else is oh, here we need to turn it to a reference, but it will make some issue for us because it's not actually reference. What we can do here, no problem. I know that it's not something good to do, but actually I'm not. So the problem is very hard. If 0, if it's like this, I'll go for that. I will clean up the code and put the clean code finally. Don't worry. So it will be dp of I, L, R, last. Oh no, last is first like that. L, R, max streak, and then a streak. Ah, it's mask, not max. Okay, got it. Okay, and then okay, L R L R L R L R L R. So these are calling this one. What about this? This is good to go. L, L, R last. Everything seems good here. So we set ans to this. So we are calculating layer by layer dp. And we keep L and R to make sure that the numbers we are picking are lying in L and R. And this dp. This dp calculates what we want here. What is this dp? This is good. This is good too. Okay. So we calculated what we wanted to calculate. But And now let's iterate over I, then row streak, then color streak, and then let's iterate over L, which is like this. Then let's iterate over R, which should start at L. And now, yeah. And now we want to calculate the number of options that they are. All elements are between L and R in the row, and now we want to calculate what happens per column. So CL we need to determine, and CR we need to determine. So CL is the least element that can happen, that can appear in columns. We're calculating that so what we have here is L plus L minus last should be like this. So CL is at least last minus L. CL is at least last minus L. So it's maximum of 0 and last minus L. Last layer is right. This is wrong. Where I used N. Okay. Okay. And we have here CR, which is the minimum of. Okay. Let's say I plus R, no, R plus CR minus I should be less than D, right? So R should be less than D minus 1 minus CR, what? CR, R plus I, so this goes for CR, the minimum of these things. So we can make it like this. So finally we will multiply dp and I will define a function dp pure. I will show you. And dp pure of n I l r row streak times n I cl cr color streak. And so what remains is calculating dp pure. So dp pure is something like the above function. I created it in order not to counting some options twice, so it works just as the above function. So it's like we have L and R, but it's possible that we didn't use both of them, so we need to deduct the number of redundant options here. So return dp in NLR last max streak, but wait, oops, why last is here for this one, but here for this one? What is happening? seems it's my mistake. Okay. Okay. And then S, then L, then R, then max streak minus the same as this one minus the same as this one plus this. So it's very simple exclusion inclusion. If L and R are equal, then you just need to print this dp, that's it. Return this dp, that's it. Otherwise we do that. What is this saying? Condition is always true. Historic is always minus 1. Ah, okay. I know that. But let it be here, just for clarity. So let me run this code, but I'm super afraid. Oops, not finishing at all. Okay, let's put some return here. It's not finishing at all. Let's put some return here. I'm sure it finishes, but maybe recursive DP calls, or what? Okay. Let's make a breakpoint here and then run. Okay, it's happening a lot of times. So D last is L last is less than, maybe, yeah, seems that here is the issue. Okay. Somehow it's counting options 10 times. It's counting options 10 times. Okay. It is more than or return 0. Or maybe we could put some answers here. As there is less than or equal to or will it satisfy? Yes, it's satisfied for sure, because yeah. Then why this is happening? When we fix L and R, why this is happening? Let me debug. Okay, finally I was able to fix the bug. One of the bugs was here, and another one, the important one, was this. I fixed them both, and now it's printing correct answer for this case. Let's test others like this one, and which is correct, and this one, which is also correct. I hope that it gets easy. Let's submit to see what happens. Okay. It's going. Still going. Easy. Oh, it was a very mind-blowing DP problem, full of implementation. I don't expect anyone can solve this during the contest, but let's see. Okay, we finished it.
Thanks for watching. If you found this video useful, please like, subscribe, and ring that bell. By the way, YouTube thinks the video down here is just perfect for you. Give it a watch and let me know in the comments.